Now, as was mentioned, we can use transformations to help us find information about other logarithmic graphs. So we have an entire listing of how graphs can shift, up, down, horizontal, how they can compress, reflect, all those types of things that we've already been accustomed to with polynomials and exponents. The same patterns apply as well to logarithms. So a lot of these shouldn't feel too unfamiliar to you other than they're with a logarithm. So let's look at an example here of how we can find some information out. So let's imagine that we have a function f of x equals log of an x plus 3 base 4. Okay, we're just going to look for the general graph, and what I want to know is I want to know what the domain of this particular graph is. So do you think we can find that out? Well, let's just draw a basic sketch of what this graph is. What's the basic graph of just a log of x? Well, remember, it has some type of a graph that's going to approach and heads off in that type of a direction, where it approaches this value, y or x equals 0, asymptotically. Well, what does it mean then when we add a value with inside of that particular value of x? It falls here, so this is a shifting of the entire graph over 3 spaces. So the graph is going to get shifted over, and x equals -3 now becomes the asymptote of this particular graph. I could draw that similar to each other. That's what the intent was. However, what we're needing to find out in this particular graph is, well, what's the domain of this new graph? The original graph, the blue one, the domain was 0 to positive infinity. The domain of the shifted graph now is from -3 to infinity. Notice that -3 is not part of the domain because the graph doesn't touch or cross -3. It just approaches it asymptotically. So the domain of the shifted logarithm over 3 units, its domain is also shifted over. Well, not shifted over, but it includes 3 more units to the left.